This podcast is sponsored by QCon AI, the Applied AI conference for software developers. Focusing on the practices of artificial intelligence and machine learning, QCon AI takes a different tack than most other major software conferences in the AI ML space today. Rather than focusing on data scientists, QCon AI targets how full stack software engineers can apply machine learning and AI techniques in their day-to-day roles. QCon AI takes place in San Francisco, April 9th through 11th, 2018. You can find out more about the conference online at qcon.ai.
Welcome to the InfoQ podcast. My name is Charles Humble and I'm InfoQ's editor-in-chief. In this episode, I'm going to be speaking to Cathy O'Neil. Cathy is the author of the blog mathbabe.org. She was the former director of the Lede Program in data practices at Columbia University Graduate School of Journalism and was employed as a data science consultant at Johnson Research Labs. She earned a mathematics Ph.D. from Harvard and has recently published a book called Weapons of Math Destruction. Cathy, welcome to the InfoQ podcast.
So glad to be here.
So firstly, congratulations on the book, which I really like. I think it's excellent. Can you maybe give a brief summary of your central thesis for people who haven't yet had an opportunity to read it?
Sure. I maintain in the book that there is a sort of class of pernicious algorithms that are increasingly controlling the society and choosing winners and losers. And these are big data algorithms. They're disguised as sort of pure positive innovations, but they're actually they're nothing of the sort. So I pick out the kinds of algorithms to worry about. Like I certainly don't worry about all algorithms. Like the Netflix movie suggestion algorithm is almost a pure good in my opinion. Lots of algorithms are not important enough to care about. But there are a class of algorithms which I call weapons of math destruction, which I do worry about. And they're characterized with three characteristics. The first being that they are widespread. They affect a lot of people with important decisions, important life decisions. So like whether they can go to college, whether they can get a job, how long they go to jail, things like that. The second characteristic is that they're somehow secret. It usually means that people who are targeted by these algorithms don't really understand how they're being targeted, how their score is being computed. They're mostly scoring systems. And sometimes it means they don't even know that they are being scored, that the actual model is invisible to them. When you have an invisible algorithm, or at least when you don't understand how it works, it won't surprise you to hear that you often find that these algorithms are unaccountable, and you can't appeal your scores if you know them. The final characteristic is that they are destructive. They kind of ruin the lives of people who are considered, the losers of these scoring systems. Usually there's an element of unfairness, discrimination, or a meaninglessness to the actual scoring system. And moreover, the destruction often manifests in a larger sense. It often actually creates a negative feedback loop that undermines the original intention of the algorithm, which is sometimes really good. Sometimes you have these big society problems that we're trying to solve. We're trying to solve them with the help of data.
Right.
And we think we have, but we actually haven't. And not only are we not solving the problem, but we're making it worse. And that's the kind of thing I worry about.
So that's really interesting. There was a thing that I was struck reading the book, and I don't think you make the connection explicitly, but I was kind of thinking of a parallel with the rule of law, in the sense that with law you can go and read it and we can kind of understand it, and here we have ways of doing that and debating it and collectively as a society deciding whether those things are happy or not. I mean, we could argue that some of those things don't work as well as they might, but in principle it's very open. Whereas with the mathematical models, they're basically black boxes, which are very difficult to reason about, even if you know what's going on. And for people without a background in the field, it's pretty much impossible. Do you think that's kind of like a reasonable parallel or a reasonable analogy to draw?
Oh, yeah. I think I even mention it in the book at some point, that in certain cases, especially when you're talking about the algorithms that play a part in the criminal justice system, like policing and sentencing and paroling, especially when you think about that, it does play the role of a part of the law, part of the system of law. And the fact that these algorithms, for the most part, are proprietary. They're not available even to the people who are targeted by them, even to people like me, If I file a Freedom of Information Act request to get the source code for these algorithms, I will be denied because the big data companies that create them, it's their business model to keep it secret. And yet people are going to jail for more time or less time because of the results of these scoring systems. So I think that they're tantamount to a type of law. In this situation where, as I said, we've done the triage, where it's big, it's widespread, and making important decisions about a lot of people. So those are the things I think of them as kind of digital algorithmic laws, and that I think we should have the same kind of protections that we do with laws, which is basically constitutional. Like we are supposed to be allowed to know what the rules are, and I think that should hold true for these powerful algorithms as well.
Right, and you mentioned a bit, there's something that I must say wasn't an area that I really knew about, but there's sort of predictive policing models that Chicago and various other US police forces are using, where the evidence that those things work is, should we say, patchy at best, and in a lot of cases they seem not to do what people imagine that they do.
Yeah, I mean, look, the way to think about it is, in the United States, aggregate statistics on who smokes pot, who smokes marijuana, would tell us that whites and blacks smoke pot at basically the same rate. But at the same time, the prevalence of who gets busted for smoking pot, who gets busted for low-level, drug crimes, it's completely disparate. Like you see that blacks get arrested 2, 3, up to 10 times more often than whites, depending on the jurisdiction. And what you realize is that it's much more, and by the way, this is the data coming out of the policing system. So, and that very same data is going into these algorithms that, the algorithms, the predictive policing algorithms, all they are things that look for patterns. And if they see patterns of criminal acts in certain over-policed neighborhoods, namely black neighborhoods, then the predictive policing algorithms will tell police, go back to those neighborhoods and look for crime. So what happens is you have this sort of feedback loop where you go someplace, you sort of bust people for low-level crime. By the way, to be clear, this is crime that would not be reported if there were no police there.
Right.
And it's the most predictable type of crime because you can find it, you can discover it, you can in some sense create it if you have a nosy enough policing approach, which we do, as we know. So we have this data going into the predictive policing, which is, essentially biased. It's racist, biased data. But for some reason, once we end up with this predictive policing predictions, people imagine that since it's scientific, since it's mathematical, since there are mathematical elements to it, it must be objective, it must be truth. It's because they don't really understand how algorithms work. And they don't understand how bias in a data set will manifest to biased outcomes.
Right. And I mean, to kind of be clear about that, then what we're saying is that flawed data, for example, can result in an algorithm which is effectively racist or sexist or whatever it happens to be, right?
Absolutely. I mean, and listen, if I had my way, if I were asked how would you fix this problem, I would say we have to stop including nuisance crimes, broken windows policing type crimes in our data set. Because first of all, as I said, they're very easy to predict. And second of all, they create these feedback loops where you send police exactly right back to the same neighborhoods. Another way of saying that, by the way, is if the police had gone to Wall Street and, arrested all the bankers at the end of 2008, then these same predictive policing algorithms would be telling the police, go back to Wall Street. That's where the crimes are. That's where the criminals are. Shake them up. And then, of course, they'd be finding the cocaine, Right. That's not what we're seeing. What we're seeing is a digital echo of our police practices. But having said that, if we could just focus only on violent crime, the crime that would have been reported in any case, like murders, then number one, what you would see, it's much, much harder to predict much more hard to predict, because these predictive algorithms would be much weaker. That's one of the reasons they don't do this. But it would also stop feeding into this feedback loop.
Right. Yeah, that makes total sense. So in terms of approaches to dealing with that kind of problem, I mean, you've mentioned one there. Are there other things you can do? I mean, can you, I don't know, decorrelate the input variables so that the model is not statistically correlated to a particular factor? Does that work? Is that useful?
I think that's absolutely something you should try. I mean, when I worry about justice models in the justice system, I worry about these recidivism models, which judges use to sentence defendants. They not only rely on these biased data sets from police interactions, they also rely on sort of ridiculous questionnaires, each question of which is a proxy for race and class. Things like, did you grow up in a high crime neighborhood? Those are all so slanted. They're sort of picking out the race, picking out the class,
right.
And they're guaranteeing somebody who's coming from a poor black neighborhood to get a higher risk score just by dint of where they grew up, where they were born. Should we decorrelate? In this situation, decorrelating the input variables would simply be saying, no, you cannot ask a question like, did you grow up in a high crime neighborhood? You have to ask questions like, what did you do? Like, what is your actual past history? And
right.
Even that, again, is a little precarious if you get caught more doing things that other people don't get caught doing. It's tricky. So I would say, yes, absolutely, decorrelate in advance, but also that's not enough. You also have to check post facto. You have to check your scoring system to see whether there is disparate impact, to see whether it does end up being discriminatory. Let me give you another example, if you don't mind.
Sure.
There's a lot of algorithms that are being used more and more in white-collar jobs to sort resumes. And, basically the way an algorithm like this works, machine learning algorithms say, is you have a bunch of historical data. Maybe you're at a large company. You have lots of history of resumes. Some people got hired. Some of those people who were hired and went on to be successful, which you define, right? Success is something you get to define. You might define it as like they stayed for 3 years and they got promoted at least twice. That might be your definition of success.
Right.
Then the machine learning algorithm would be tasked with looking for patterns of those people who became successful, and then saying, of the people who are currently applying to work here, which ones look like people who were successful in the past? Now this is what a machine learning algorithm is good at. It's good at looking at historical patterns and matching patterns. And it seems completely unobjectionable. It seems like there's no agenda there. But now imagine that Fox News started using that machine learning algorithm. What you might see is that the female applications are filtered out. Because why? Because females weren't historically as successful at Fox News. Now, the thing about the machine learning algorithm is it doesn't ask why. It doesn't say, hey, maybe there was some kind of culture within Fox News that prevented females from succeeding. It simply doesn't ask that question. It just looks for patterns and repeats them. So what I like to explain is, like, if we have a perfect system by which we hire people, then by all means, let's automate it. But if we have an imperfect system and we automate it, then we are repeating our past mistakes. And by automating it, by codifying it, we're actually making it more difficult to improve ourselves and to improve those processes.
Yeah, that makes total sense. You said in an article you did for Slate that people have too much trust that numbers are intrinsically objective, I think was the phrase, which I kind of really like. Can you unpack that a little? Are you talking about kind of the end users of the algorithms, or does that extend to data scientists themselves?
I think there's like a human, for whatever reason, there's like a human nature whereby if someone is scored with numbers, if everyone knows their score, and if it's a bad score especially, then there's a moral element that comes into play. Like, if you're given a bad score, I somehow automatically assume it's your responsibility. And this is, so that's number one. So people somehow, they stop thinking about why. They stop thinking about causation. But then, even if prodded to, they often think, well, it's mathematics, it's complicated, I'm no expert in mathematics. In fact, I'm afraid of mathematics. A lot of people tell me they're afraid of mathematics. So they somehow just kind of get weak-kneed in front of the concept of a scoring system, and they have this added bias towards assuming it's objective. Whereas, like I just described an example where, the Fox News, if they were scoring resumes for possible future anchor women or men, it would clearly not be objective, but yet there would be a scoring system there. People, I'm just saying people are afraid of mathematics, and they also trust mathematics, and this combination keeps them from questioning those scoring systems.
Right. And something that you also said in the book, which I found very striking, was that data scientists aren't paid to think about these kinds of things. And I was kind of surprised about that. My background is more in computer science, and I certainly wouldn't want to suggest that we develop beautiful bug-free software all the time, but testing is very much a core part of the discipline, and this feels like a testing problem. Am I missing something? Is that very naive?
Yeah.
Or?
So here's the thing. I want you to compare two different problems. One's a problem in computer science. One's a problem in data science. The computer science problem is the classic problem, like that MapReduce solved, which is like look at frequency of words in a corpus. Just count how many times each word is used in a long text. And if it's big enough, you need like an entire grid of computers and MapReduce to do it. Whatever. Like the point is, a computer scientist can they know what they want to end up with. They want to end up with like a list of the words with counts next to each word, and they want to optimize on how long it takes. As long as they come up with a way of doing it that's fast, they're good. They've done their job as computer scientists. Now think about a data scientist. They're in a company and they're told, figure out who's going to buy a hotel room for 3 days. This is something I was actually tasked with doing. You have all the data from Expedia and cheap tickets at your fingertips. Like look for a score of likelihood of purchasing a hotel room. Okay. What's the thing I want to end up with? I want to end up with, literally for each person, look at what I know about them and end up with a probability of them purchasing hotels. That is not well defined at all. 3 different data scientists will come up with 3 totally different algorithms to do this. And they might even be equivalent in terms of accuracy, depending on how you define accuracy. But there are choices along the way as to which attributes they used, which algorithm they used, which hyperparameters they tuned, and how they tuned them, absolutely matter to the end result, the end probability model. And so we just have so much more leeway. Some of us might have used the characteristics we know about these users, and maybe we look at axioms profiling of them and figure out what their zip code is. Figure out a fuzzy match with their zip code. So we kind of guess their demographic. That kind of information might add to the accuracy of our model, but it might, at the end of the day, end up being a discriminatory model, depending on what we're going to do with this model. If we're going to give opportunities to some people and take away opportunities from other people, using demographic data might improve the accuracy, but actually make it a bad model in the sense of fairness. Anyway, I hope that wasn't too long and complicated an explanation, but the point is that computer scientists' jobs are somehow more well-defined than data scientists, and data scientists literally have to make ethical decisions during their job, even if they don't acknowledge it, which they often don't.
Right. That's really interesting.
Let me give you another.
Yeah.
I was talking to somebody who actually builds recidivism risk models for a state prison system. Mm-hmm. And I asked him, do you use race to improve the accuracy of your model? And he said, oh no, I would never use race, because then you'd have like these racially, discriminatory outcomes, and that's not okay. And I said, well, do you ever use zip code? And he said, oh, I sometimes do, yeah. And I'm like, well, zip code is a proxy for race, considering how segregated our society is. And he was like, yeah, I guess so. And I think the most important part of this conversation was that I said, is there anyone within this state government that you're working for as a consultant, that asks you these questions, that tells you what the rules are, and that questions whether your end result is discriminatory? And he said, oh, there's no one there. This is up to me. They trust me. I have a Ph.D. I keep these decisions at arm's length. And he literally told me he doesn't feel like it's his responsibility for how they're used, because he's just doing the technical side of things. And in the meantime, of course, the people at the state level, they don't think it's their responsibility to think about how the algorithms are created, because the nerds do that, and they're just going to apply them. So there's this sort of meta issue, which I've gotten more and more interested in as I wrote this book, which is like, what are the conditions that make it ripe for having a weapon of mass destruction? And I've come to the conclusion that an abdication of responsibility is a critical ingredient. Like, there has to be some sense in which nobody wants to take responsibility for actually really tricky, socially complicated questions.
Very cool. Very, very interesting. So we've talked on some of the things that can cause issues with the model, like having flawed data to start with would be an obvious one. Are there other things that can cause problems with the models that are maybe a bit more subtle or a bit less sort of obvious? Yeah,
I mean, the sort of the model that got me started on this long trip was the teacher value added model, which is a sort of nationwide trend in my country to sort of find the bad teachers. It's kind of very much depends on rhetoric about, solving education and improving test scores. And it depends on the idea of getting rid of bad teachers. And the way you get rid of bad teachers, you find bad teachers using these data-driven assessments, and then you fire them. Essentially, that's the second step. But you have to find them first. And the way they're attempting to find them is just statistically weak. It's almost, basically it's a scoring system where everyone gets a score between 0 and 100 for each class they teach each year. And then they just basically think, okay, if you're a bad teacher, you're going to get a low score, and if you're a good teacher, you get a high score. It's simply a random number generator. It's not entirely a random number generator, but it's almost entirely a random number generator. So I talked to a teacher who got a 6 out of 100 in 2010, I think it was, and a 96 out of 100 the following year. He did not change the way he taught. Right. He's been teaching for 26 years. I found another teacher who got fired because she got a bad score, even though her principal loved her and the parents loved her. She immediately got picked up by a richer public school system that doesn't use this system. This system is almost entirely used in urban districts. So, and this is what I was talking about with the sort of larger destructive feedback loops. What you have here is the original intent was find bad teachers, get rid of them, right? The actual application of this regiment, which is essentially arbitrary punishment regiment, is that good teachers leave the system. They don't want to work under those conditions. And we now have a nationwide teacher shortage. And guess what? Nobody wants to think very hard about why that's true. We've been blaming teachers, and we've been kind of arbitrarily putting them against the firing wall. And this is the sort of mathematical weapon we've used. But anyway, in any case, to be clear, the flaw of this algorithm is that it is not very informational. And yet we trust it. Because why? We shouldn't. But the point is that the teachers don't get to appeal their score. They don't get to understand it. They don't have nobody suggests how they can get a better score. It's simply a number that's handed down to them, from algorithmic gods.
So how would you go about auditing a model? Suppose, I don't know, you said to Google, hey, Google, I want to come in and audit how your search algorithm works, and they went, sure. How would you then go about that? How would you approach it?
it's extremely, and by the way, I want to do this. This is where I appeal to your audience, because I need computer scientists to help me, because this is the goal for the rest of my life, is to be an algorithmic auditor. I don't want to give the impression that I have all the answers. Like, it's a very new field. The tools are being built. But let me give you an example of what I would do with the teacher's model that I just described. I would have to refer to a ground truth. Like, there has to be some ground truth here. Like, is there some sort of maybe expensive way, some qualitative way of describing who's a good teacher, who's not, right? And by the way, there are plenty of ways to do that, and people claim they're too expensive. Okay, they're really expensive, but how's this? We won't use this inexpensive data-driven version of it until it agrees with the expensive one, like, closely. So do it in small batches for, 2 different school systems, until we get a sort of automated version of something that we actually trust, and it's very close to something we actually trust, and then we can expand it slowly and carefully. That's not what we're saying. In fact, there have been a couple head-to-head comparisons of this cheap value-added model, random number generator-ish algorithm with expensive qualitative approaches to assessing teachers, and they do not agree very well at all. Not at all. Like, 24% agreement in the correlation. Okay, so that's that. In terms of Google search, it's so massive, right? And I'm sure your audience is grumbling, thinking, how could anyone do that? And the answer is nobody could do that. not in like one fell swoop, and not in one direction. The point is, and this is why I keep talking about triage, like, you cannot worry about everything. You can worry about certain things. You can think about what really affects people. Okay, so LaTanya Sweeney did a little bit of this auditing for the Google search, because what happened was she Googled her own name, and her name is LaTanya Sweeney. It's an African-American name. And she saw the results. There was an ad that said, would you like to look at the police records of LaTanya Sweeney? And she's like, police records, arrest records, I wonder who gets that kind of ad when you search for their name. And so she did a kind of comprehensive test on this, and found that black-sounding names get arrest record ads. White-sounding names do not. I mean, to simplify it. It's statistical, so it's not black and white, as so to speak. The point being that is a situation where you will get Googled when you apply for a job. Because everybody Googles people when they're applying for jobs. So it is a reasonable assumption that this will affect you in a long-term way, in an important way. So this deserves auditing. This rises to the levels, I would claim. Maybe you would disagree, but the point is, like, it's going to be a series of case studies when it comes to auditing Google search. What deserves scrutiny? What's important to society? What creates or closes off opportunities to people? And how do we check whether it's fair? And then we actually go ahead and do that. And by the way, like, Google, there's no one at Google who's like intentionally racist, I don't think, who's like creating like a little subroutine called "do racism." It's really very, unintentional, I should say. It's a product of our society. Like, Google it seeks out and finds patterns and repeats them. It's just very much like I talked about with the Fox News machine learning algorithm example. That doesn't mean that it doesn't have influence. So I think the most important thing I'm trying to get across to Google, whoever in Google reads this book, is that they do have to take responsibility for this. They have tremendous power, and they with great power comes great responsibility.
So you make an argument in the book that more government regulation may well be needed. And I was reading an article at the weekend about attempts by Google and some others to come up with some sort of self-regulatory framework. I kind of know the answer to this question because you put something out on Twitter about it, but I'm curious to know what your take on it is.
Well, I don't have a problem with them talking about this, especially if they come out and say, yeah, you're right, we need to think about this, it matters, and we welcome public debate about this issue. What I have a problem with is the idea that they're simply like stemming a PR disaster and getting ahead of it with a bunch of lawyers and PR experts. And they're going to come up with something that sounds good but doesn't do anything and does not include a public debate. Because the truth is, time and time again, as you know, speaking as a white, privileged, educated technologist, I find that the people who are like me do not worry about the things that actually affect people. So their perspective on what the actual problems are, what they should be focusing on as possible ethical concerns, I just don't think their universe of concerns is wide enough. So they really need like a diverse set of voices to say, here's what I'm worried about. Here's how Google search affects me, or whatever Google product it is, not just search. So I don't think it's sufficient. I don't think it will ever be sufficient for them to have secret negotiations and talks with each other. When I say each other, I mean IBM, Microsoft, Facebook. Those companies are made up of a relatively homogeneous group of people who are almost always on the benefiting end of these data science scoring systems. And as such, they do not really have the perspective that is needed to think through what could go wrong.